Good afternoon, everyone. In today's lecture, we will discuss various non-destructive testing techniques. So, what is the meaning of non-destructive testing? Non-destructive testing has been defined as comprising those tests used to examine an object, material, or system without impairing its future usefulness. So, last time we see that we are discussing some destructive types of testing. In this destructive types of testing, we have to crush the sample or the specimen whose strength is to be found out. Okay. Now, in case of non-destructive testing, we are not destroying our specimen or our object. Okay. So this is the advantage that without destructing the material or the object or the system, okay, we have to find out what is the strength of the system or the material. That is called your non-destructive testing. What is the characteristics? It applies directly to the product. Okay. Tested parts are not damaged. We did not damage the concrete whose strength is to be found out. Various tests can be performed on the same product. You can apply various tests, more than one test, okay, on the same product, because we are not destroying the product. We are not destroying the sample or the specimen. Specimen preparation not required, can be performed on parts with which are in service. Suppose that we have to find out the strength of the various members in a building. Suppose that we have several columns are there, beams are there, slabs are there, and which are, suppose that that building is constructed 50 years ago. Okay, so we can easily calculate what is the strength of various members, what are the strength of the column, the beam, and the slabs. Okay, so these tests can be performed on parts that are in service without destroying it. So this is the main advantage of non-destructive testing. Low time consumption, low labor cost. Okay, so these are the characteristics. Now, what are the objectives? Our objective is to evaluate the strength of the concrete. Main target is to calculation of strength. To ensure product integrity and internal reliability, to detect internal flaws. Apart from calculating the or evaluating the strength, we also detect what are the internal flaws in any structure. Where are the internal cracks which you cannot see? So this can be easily determined with the help of non-destructive test. To determine the thickness of concrete layer. Suppose that you have a road is already constructed, okay, RCC road, okay, and you did not know how much the thickness of concrete is provided actually in the road. So non-destructive testing gives the exact thickness of the concrete layer. Similarly, you have to evaluate the corrosion of reinforcement concrete. If suppose that a structure in use for a long period of time, so there are chances that the corrosion of steel will be there inside the structure. So how to judge that the corrosion of the reinforcement in the concrete is taking place or not? So with the help of non-destructive testing, we can easily find out the corrosion of reinforcement in concrete. To determine the voids behind the concrete surface, another objective, to ensure customer satisfaction. Suppose that generally in the life of the structure is 50 years, and suppose that any building has passed that life, and the customer or the inhabitant wants to verify whether the structure is safe or not. So for customer satisfaction, you have to do the non-destructive testing and give the report. To evaluate the chloride penetration in concrete. Okay, so this chloride penetration is responsible for corrosion in the concrete. So you can easily calculate the chloride penetration in concrete. To evaluate the alkali aggregate reaction in concrete. Another harmful effect in concrete, that is your alkali aggregate reaction. What are the advantages? Access to hidden items, better investigation with NDT, rapid accumulation of data. You can collect so many data in quick number of time. Generally less expensive than destructive testing. So in destructive testing, you have to prepare the cube, you have to cure those cubes for 28 days, and then go to the laboratory, okay, and then testing will be done. Okay, so it takes a lot of time and money and the resources. So generally these non-destructive testing are very quick. minimize interruption of building services. So for non-destructive testing, the building uh, services is gone as usual. Okay, so there is no interruption of the building services. Evaluation and quality assurance disadvantages. More than one test method will be required. In some instances, you can apply more than one test. Environmental condition may affect the results. Okay, suppose that humidity or the temperature will affect the result. So this is one of the disadvantage. Some condition cannot be determined with a reasonable degree of accuracy without destructive testing. Sometimes without destructive testing, you cannot find accurate results. So this is some of the disadvantages. Now, what are the various methods? Basically, there are traditional methods, which includes visual examination. Just looking at the eye, by the eye, you can judge the uh, any defect in the specimen. Second is your rebound hammer test to evaluate the surface hardness of concrete. If you want to find out what is the surface hardness, then go for the rebound hammer test. Ultrasonic inspection to measure the pulse velocity of ultrasonic waves and hence concrete work. With the help of these waves, ultrasonic waves, you can correlate the quality of the concrete. We will discuss later on in detail. But now there are some in situ examination. In situ means surface cracks anywhere, okay, or delaminations there inside the concrete. We have chain drag. We will discuss this later on. What is this chain drag? Now recent developments. We have infrared thermography. That is one method that is called recent developments. Resistivity of concrete. Second, image processing, just like X-ray. Okay, if you want to see any crack in the bones, so doctors perform the X-ray. So same technique is applied for concretes for detecting any cracking inside the concrete surface. That is called image processing. Acoustic emission, ground penetrating radar to detect position of reinforcement bars. Now you will not know where are the reinforcement is provided under the concrete. Okay, so if you want to know the location or the position of the bars, okay, then go for ground penetrating radar test. Electromagnetic methods are there. Eco impact test is also there. Half cell electrical potential method. So this method is used to detect the corrosion potential in the bars. What will the corrosion potential? Then go for this method. Permeability test to measure the flow of water through the concrete. Okay, and we have some sonic methods also. So these are some recent developments. We will discuss one by one in detail. Now, first one is your visual examination. So what you will do, you will to see here by looking through the eye. The eye is your first tool where you can detect many problems. So it is nothing but your first tool for any inspection. Okay. So prior to any further non-destructive testing, a thorough visual inspection will be carried out. So which test you have to perform on any structure, what you will do? First look through their eyes and then decide which method we will use. Okay, so that is called your visual examination. Over 90% of defects are found by the naked eye. Okay, so by looking at the surface, most of the defects can be verified, can be detected. Okay, and you also decide which test have to perform for further investigation. Now, first is my rebound hammer test. This is your rebound hammer. Okay, this is your rebound hammer, and how it is performed, I will just show you in the next slide. Okay, so what is the principle here? Extent of rebound. When you push this rod inside with the help of some force against the material to be tested, what will happen? It will rebound. Okay, and we have a scale here. This is my scale here, and these are the some graduations here. So when this hammer rebounds from the surface, what will happen? You got a reading here. You got a reading here in the form of a number. So using that number, we have a chart which is given here on the instrument itself. Okay, so this chart will give you, this is my compressive strength here. Okay, and we have a one more axis here which is nothing but your rebound hammer here. So just suppose that this your rebound hammer, just go straight here and you will find this is the strength of the concrete. So in this way you can perform this test. So this test will give you only the surface hardness of the material. Okay. Now what inside the concrete is there, that test will not give you anything. It just gives the surface hardness. Suppose that if you test this rebound hammer uh, against the some aggregate, stone aggregate or quartz aggregate, then it will be a higher rebound number. If it is a loose surface here, we get a low rebound number. Okay, so that's why this is not a very accurate method for uh, strength of concrete determination, where it is used to assess the quality of the concrete, assessing the uniformity of concrete. Now, this is the principle is this one. Okay, this is your plunger, that is your rod. Huh? We have a spring here inside, clear? And what we'll do first, I put the plunger against the surface to be tested, clear? And then what will happen? It will rebound. It will rebound. Now look here, if here it is void here, suppose that. If it is void, then it will not rebound to a larger extent. If we have a hard surface, so we have a complete rebound here. Got the point? So in the first case, instrument is ready for testing. Body pushed toward the test. Then we have to apply force here. Then third case, hammer is released and hammer rebounds. In the fourth case, when it is released, the hammer rebound, opposite sign here. So we got certain number here, and against that number we have to find the strength of the concrete. So this is rebound hammer test. Give the test were conducted at 6 different locations of the member as per IS 13311. Okay, so suppose that if your area is 10 by 10 square centimeter, then on that 10 by 10 you have to perform at least 6 different locations and take the average. Rebound hammer gives only the surface strength for a depth of about 0.5 inch to 1 inch. That up to 1 inch depth here, that will give you the strength of the surface. Okay, so suppose that if anything beyond 1.5 inch, that will not given by this method, rebound hammer test. So that's why it is less reliable, because it gives only the surface property here. Okay, and generally rebound hammer gives higher value, higher strength than the destructive test. So that's why it is your less reliable. Now we have, suppose that I have to test this wall here. So I have to put in the horizontal direction, push this hammer against the wall, and then we have a rebound. That rebound number is read with the help of this scale. So we have a correlation chart here. This is cube compressive strength, and we have rebound number. Okay, so we have different curves are given, which are established by different scientists. Generally, we are using this one. This one. Okay, suppose that my rebound number is 30. So I will go here and then see what will be the compressive strength. This is my compressive strength, that is your M30. So against rebound number 30, I got approximately 30 MPa the strength of concrete. Now what are the limitations? The first thing is that it should always be perpendicular to the tested surface. Okay. Now affected by form material, that is the type and the smoothness. The surface is smooth or not, that is affecting the results. Okay. Aggregate closeness to the surface. So any quartz aggregate is just under this rod here, so we get a different result. Steel reinforcing. Suppose that any steel is there inside the concrete, which is just below this, you can say that the rod, then we have a different result. So steel reinforcing, closeness to the surface, it is affected. Moisture content, it is affected. Surface finish. Okay. Hammer orientation. Hammer orientation is important. Always apply this hammer in a perpendicular direction to the surface. Now we have this second method, that is called ultrasonic pulse velocity test. Okay, we also call it that Pandit, P-U-N-D-I-T. Pandit means portable ultrasonic non-destructive digital indicating tester. We have a long name, that's why the short name is called Pandit. Okay, so what the we'll do, we have two transducers. This is the transducers. This is my specimen. Okay, This is one transistor which emit the ultrasonic waves. This is another transducer which receive the ultrasonic waves. So we have this transmitter here that is emitting the ultrasonic waves. We have this length of the sample. We have a receiver here. This receiver receives these ultrasonic waves, and this is connected to a timer in the display. Okay, so here in here we are having some digital display here. So that digital display will give you the time of travel from here to here, how much uh, time, uh, how much is the travel time by this ultrasonic wave. Okay, and you know that distance here. So with the help of time, you can easily find the velocity. Okay, so with the help of that velocity, we can easily assess the strength of concrete. How it is assessing, I will show you later on. Okay, so this is the principle that the velocity of longitudinal wave depends only on the elastic property, that is the density, homogeneity, and uniformity of the material. Now, in this test, the velocity of ultrasonic pulses is 54 kilohertz. So we are measuring the time taken by the pulse to get through the structure. Higher velocity, if you get higher velocity, this indicates the good quality. If their velocities are slower, we have the cracked concrete, or we have certain voids and cracks inside the concrete. Clear? Now, this is the Pandit that I just tell you the full form of this Pandit. Portable, ultrasonic, non-destructive, digital indicating tester. Okay. So this gives conservative estimate of strength lower than the destructive strength, that is safer side, because it gives the lower strength to the destructive one. That's why it is on the safer side. Now, how to do this test? Okay. So look here. This is my tester. This is one transmitting transducer. This is a receiving transmitter. This is display here. Okay, we have ultrasonic wave generated, which is passing from here, receiving from here, and we have a digital display. So you will see how to perform the test here. So one transistor is here, another is here. This is testing of beam, any testing of beam. So basically, gives an estimate of the compressive strength of concrete on the basis of recorded ultrasonic velocity. So based on the velocity of these ultrasonic waves through the materials, we judge the strength of concrete. Now, interference from presence of reinforcement should be accounted. Now, whenever there is a reinforcement inside the concrete and with the ultrasonic pass through that reinforcement, okay, so the velocity will increase. So before applying for this test, we have to account for the reinforcement location also. Now, what are the different types of transmission? If suppose that this is my column and we have to test this column, so one transmitter is here, the receiver is here on the opposite sides, exactly at 180 degree apart. So this is called direct transmission. These are the ultrasonic waves. This is called semi-direct transmission. Suppose that we have a beam, and we have to test this one on this face and another on this face. Okay, then it is called semi-direct transmission. And we have indirect transmission. Suppose that I want to test the slab. So in the slab, it is not possible to set the transmitter, one transmitter here, another on the lower side. Okay, or suppose that if I want to test the pavement or the road surface, CC road surface, then I have to put the transmitter on the same side. So that is called your indirect transmission. So we have direct transmission when all the faces are available for testing. Semi-direct when two faces are visible to you. Okay, and we have if only one surface is available for testing, like the road surface, then we go for the indirect transmission. Before using this instrument, I have to apply grease here on the transmitter so that the ultrasonic waves which are generated, they are not leaked. Okay, and we have proper contact between this one and the material which we have to test it. Okay, so this is, suppose that cube is testing here, we have to apply grease here, grease here, grease here, and we have this type of digital this one. Okay, so we have this pulse velocity which is also recorded. So this is in meter per second pulse velocity, which is also, and we have a time here. Time is always recorded in microseconds. Okay, So on the digital display, two things are there. One is time in microsecond and the velocity in meter per second. Now suppose that if I want to test a long wall, RCC wall, suppose the retaining wall is this one. So what we will do, we have to mark the horizontal lines at a regular interval. Yeah. Okay, and we have to make a cage here in the vertical direction also. Okay, at the intersection of each vertical and horizontal line, this is the intersection. So we have to measure the pulse velocity at those locations. So we have to apply the grease here, huh? And we have to put one here and another on the adjacent one, and then see the reading. So suppose that your pulse velocity comes out to be, suppose that this is your 4, suppose that this is your 3.5 kilometer per second. Okay, so what you will do, just go it here and see what will the strength of the pump. This is my strength of the pump. Okay, now what is mechanism of signal transmission? If suppose that a crack is there, so ultrasonic wave does not pass through a vacuum here. So they will just go here and then return back here. So if any white crack is there, no signal is received. We are nothing receiving here. So no velocity will be come to your digital display. No time will be coming on the digital display. If there are voids are there, these are some voids are there, okay, or we have some cracks are there, what will happen in that case? Again, the velocity, the ultrasonic wave does not pass through the voids of the cracks. So time travel is increasing here. So when time travel is increasing, velocity is equal to distance upon time. Velocity will reduce. When velocity will reduce, the strength comes out to be less here. So you see that if the velocity is 4, we get very high strength, 35 MPa. If the velocity is only 2.5, we have only how much? 2.5 MPa. If the velocity is 3 km per second, we have only 8 MPa. Okay, so in this way, if the cracks are there inside the concrete, we get a less velocity. So less velocity means less strength. So these are the some ranges are there. If the velocity is more than 4.5 km per second, we call the excellent quality count. Between 3.5 to 4.5, we have good quality count. If it is less than 3, we have a doubtful count. Doubtful means we have certain voids and cracks are there inside the concrete. Okay. Now what are the advantages? Sensitive to surface and subsurface discontinuity. High accuracy means position, size, and shape of defect. It is quite accurate if you want to uh, locate the position of the crack and the size and shape of the defect. Minimal part preparation, instantaneous results, automated detailed images, non-hazardous, and is also portable. What are the applications? Quality control and material inspection, detection of presence of cracks, presence of voids, of rails in railway lines, okay, uh, and columns, beams, slabs, etc. If you want to find out the cracks or voids in anything, you can go for this. We have seen this application of this technology when you have the site visit of railway yard in your third year, where this technology is used to detect the voids in the rails. Inspection of aircraft sections, pressure vessels can be done with the help of this. Inspection of any pipeline or plate welds. Inspection of pins or bolts or shafts or cranks. Okay, so anything you can use in a steel structure also. You can use for pipelines, for inward or welds also. This can be tested. Detect internal corrosion also. Now application of water storage tank. Now this is a large water storage tank. What we will do? We have to use a robotic crawler here. This one is your robotic crawler that use ultrasound to inspect the wall of tank for corrosion detection or any leakage that can be detected with the help of this one. Okay. Now suppose that any underground tank is there where it is not possible to go inside and see the inside of the tank. So what we'll do? We are using the cameras on long articulated arms. So this is my arm. We have a camera here. So this is an ultrasonic camera. So this camera is used to detect the underground large storage tank for damage. Rail inspection. Rails are inspected Okay, so we have provided this non-destructive testing instrument inside this wagon here. Okay, that will give you continuously records all the data and give you the results. Okay, so for that, special cards are used to inspect the rails. Application in bridge inspection also. So bridge are usually inspected about every 2 years. Okay. Now some bridges are fitted with acoustic emission centers. We have all suppose that we have to put this is your suspension bridge here. So we have to put some acoustic emission center that continuously listens for sounds of cracks and growing. So if any unusual cracks are there, any unusual sound is there, that will this sensor will detect it and it then directly gives signals to the computer. Application of aircraft. So we have any minor cracks are there in the manufacturing of aircraft, we can see with the help of this technique. Okay. So suppose that this is aircraft window and we have any small crack is there that can be easily detected with the help of this application. Here, this is the testing of this aircraft near the wing. Now, in situ examination, we have surface cracks. How can determine the surface crack? Well, a simple procedure. Suppose that this is my tested surface, any floor is there, and we have some lamination is there, delamination. Okay, we have a certain voids is there. So what you will do? You have to just take a hammer and put it several places on the surface where you find a change in sound. So that change in sound will give you about the surface crack very easy. So you have to apply a paint there, paint here, paint here. So in this region we have a crack. Now we have a chain drag. This is generally used for checking the industrial floors. Now industrial floors are very long and very thick floors are there. Sometimes we have chances that there is a delamination is there. So what we will do? We have to these are my rollers here, and we have a chains are attached to this one to these rollers, heavy chains. Okay, so these chains are dragged. These are dragged with the help of this pulley here. Okay, on the surface, and where you find the change in sound, that will be the location of the voids or cracks. So you have to apply the paint. So this is called in situ examination. Now come to some recent technique, that is ground penetrating radar test. What is this? It uses to assess the depth of concrete members. How much depth of concrete members are there? Suppose that you want to check the depth of the bridge slab, okay, or you find out the depth of the pavement, okay, whether the contractor have used the same depth as per the specification. So go for this one. You have to use to indicate the reinforcement details. What will be the cover? What will be the spacing of bars? Used to evaluate condition of asphalt covered concrete bridges decks. Now this is the instrument which is used. You have to roll it on the surface and connect it with battery. So everything is displayed on this screen here. Okay. So we have this, this is they are doing the testing here. So these are nothing but these are giving you the reinforcement inside this pavement here. Okay, we have the reinforcement here, we have the reinforcement here. Okay, so this is again a testing of bridge deck here with the help of ground penetrating radar. These are tested with the help of these standard ASTM standards. Now come to the test for resistivity of concrete. Resistivity means measurement the likelihood of any corrosion. If you suspect that the reinforcement bars are corroded, then go for this test. That is the resistivity of concrete. Now suppose that this is my specimen and we have a reinforcement which is corroded here. So what I will do, I have to apply this called Wiener probe. We have two probes. We have probes here, 1, 2, 3, 4 at a constant spacing. So on outside, I have to apply a current here, a current. And on the inner probes, I have to measure the voltage. Okay, depending upon the reading which we get from here, if the reading is more than 100, voltage is more than 100, then it is a good quality of concrete. We did not have any corrosion here. Okay, if it is comes out to be less than 100 value, then we have some suspected some corrosion is there inside. Okay, a current is applied on the two outer probes, and a potential difference is measured between the two inner probes. The current is carried by ions in the pore liquid. So whatever the moisture is there inside the concrete, that moisture will carry the current. Now, this is the simplest instrument which is also available in our laboratory, concrete laboratory. We have a cylinder specimen, these two probes for measuring, for giving the current, and these inside probes are for measuring the potential difference. So that is given by the indicator here. So with the help of this reading, you can judge the quality of the concrete. Okay. When the electrical resistivity of concrete is low, this means that likelihood of the corrosion increases. Low means less than 100. Means suppose that 60 value got, 70 value got, then this means that there are chances of corrosion. If electrical resistivity is high, that is more than 100, okay, so this means that there are more chances of corrosion. So these are the values here. Now we have, this is your kilo ohm centimeter. The unit is different for different instruments. Here this is in given in kilo ohm centimeter. Whatever I told you before, this is in kilo ohm in other unit. That is other unit. That is the range when we discuss in other units. We have the values in 100, less than 100 or more than 100. Okay. So if it is unit is kilo ohm centimeter, actually this unit is given here on the digital indicator itself. If it is less than 5, we have high rate of corrosion. If between 5 to 10, okay, corrosion rate is high. If it is more than 20, it is negligible. Next is pull-out test. It is nothing but semi-destructive test. What I will do here, this is my concrete surface. I have to insert a pin here, okay, inside the concrete surface at the time of casting. And then what I will do, I have to apply this, an instrument, small instrument is there, okay. That instrument is attached to this thread or this needle is here, and then apply a tension force here, okay. So a force at which this needle will comes out from the concrete, that will give you the tensile strength of the concrete. Okay. So that inherent tensile strength is related to compressive strength by this relation. Suppose that any tensile strength, I got this 2.5 here, so this means that my compressive strength is corresponding compressive strength is 35 MPa. So in this way, we have to perform this test using this calibration chart. Application means where is it applied here? Provides an estimation of the tensile strength of hardened concrete. If you want to see the tensile strength of concrete, then go for this test. And this tensile strength is again, you can say that are correlated with the help of compressive strength. So you see that this is your instrument here. We have 3 legs, 1, 2, and 3, 1 here. This is my instrument for measuring the tensile force. When it is pulled out from the concrete, we have this conical shape. This needle is pulled out from the concrete surface. This is another closer view. This is concrete surface to be tested. We have make a hole here. Now specification in probe diameter is 50 millimeter. So the diameter here to here is 50 millimeter. Hydraulic capacity of this one is 10 kilonewton. This one. Depth of partial core. The depth is of this cutting core is 10 millimeter. Okay. And we have to apply a tensile force on this one. Okay. That force is recorded with the help of this gauge, and this gives you the tensile strength. Now come to the next, that is called thermography. Now in this case, thermography, what we do, we are using the infrared radiation output of the surface. Thermal gradients arise because of difference in surface temperature. So what we have to apply a special type. Let's suppose that this is my concrete surface and we have a crack here. So I have to apply a thermal radiation here, radiations here. Okay, heat source. Okay, and we have a camera here. So when there is a heat source is there, and if there is a crack is there, so thermal gradients are developed. We have a different temperature here. We have a different temperature here. So these are taken up by the camera, and this camera is connected to the software here. So that software will give you the thermal gradients, and those thermal gradients will give you the likelihood of concrete. Okay. So suppose that look here, this is a model is there, we have to apply some heat source on it, okay, and see the thermal gradient. So where the openings are there for these doors and windows, we have a different temperature. For solid surfaces we have a different temperature. So by analyzing these thermal gradient, we can easily check the quality of the concrete or detect the voids and cracks. So this application is generally used in bridge decks to see where are the cracks. Now, radiographic method, the formation of an image of the test piece on photographic film. This is just like an X-ray of a body. Okay, so in the X-ray we have to find the defects in the bones. Any cracks in the bones are there, or any fracture is there. Same application is applied for the concrete also. We have to apply X-ray or the gamma rays. So this technique is used for voids and position of pre-stressing cables and ducts. It is widely used in pre-stressed concrete members to find out where the position of cables or ducts inside the concrete surface. Okay. So this is X-ray machine or radioactive source which is used by this, either this one IR 192 or CS 137 can be used as a source of photons. Now, what is this X-ray photography? Look here. This is my X-ray source. Is this one? We have the specimen here. We have a flaw here. Some crack is there. This is my flaw. So what will happen? This will. This is my, you can say, the X-ray film, and we have an image formed here. So whatever the flaw is there, that is detected on the image here, which is here. So that image can be easily worked out. Okay. So this will give you the defect. Okay, so we have dark and light shadows on the image. Okay, just like in X-ray, common X-ray. Now, if you want to find out what will be the uh, depth of crack from the surface, suppose that this is my X-ray source is here. Okay, we have a specimen is here. We have a crack is here. Okay, and the images are obtained here. Now, at how much depth these cracks or these flaws are there? Suppose that you want to detect the flaws in a bridge slab. Okay, you did not know what will the depth here. Okay, so this depth can be calculated very easily with the help of this formula. So we have this F is given to you. So this is my F. This is the S. That is the you can say that the suppose that in the first case my X-ray source is at this location, and I got this much image here. In the second case, I displaced the X-ray source to this point. This is the distance of P here. Okay, and again the image is obtained at this point. So center of this image and center of this image is denoted by S, and we have a P here. We have a P here. So with the help of this distance P, with the help of this distance S, and this my F, I can calculate the depth. At what depth this flaw will be there using this flaw. Okay. So in this way we can find out the exact location of the crack. We have, if you want to test some pipelines, again we are using this same technology, radiographic application, pipeline of pipe beds. Electromagnetic method. So this electromagnetic method, a means of internal inspection involving the use of electromagnetic flux to the location of reinforcement. If you find out the location of reinforcement, then use for this one. Now suppose that this is your bridge deck, inside the bridge. So we have to find out where the location of the reinforcement. So just use this electromagnetic method to trace these are the reinforcement. Okay. Magnetic particle inspection. If you want to test a pipeline, so this is your joint. This is larger diameter pipe, smaller diameter pipe. We have a joint here. So if you want to see whether any crack is there inside this location, what you will do? You are using a dye pigment. Okay, and these particles are magnetized. You have to apply iron particles inside a special dye. Okay, and you have to pass a magnetic field lines. So these are the magnetic field lines. Suppose that this is a crack is here. So what will happen at the location of the crack? All these particles are accumulated at one position because of these magnetic field lines. So this you can say that this indicates the location of the crack. So this is called your magnetic particle inspection. Next is impact echo testing. It is used to measure the thickness of concrete slab pavements. And application, location of internal defects, void, lamination, internal damage. So with the help of some electronics, we can easily judge the thickness of the concrete and the cracks in the concrete. This impact echo testing is done with on this wall here, on this beam is here. Now what is summary? It required significant experience, powerful method for flaw detection. Okay. Suppose that we have some pre-stressing cables are there inside this pre-stressing girders, and we did not know whether these cables are corroded or not. Then we go for such type of test. Application to quality control, verification of test results is critical. Hmm. The last method is your cover meter. Okay, this is also available in our laboratory. So it is used to measure the spacing of steel bars inside the concrete surface. If you want to find the spacing, this is one more method. The diameter of the bars can also be read out with the help of this instrument. Thank you so much.